I'm gonna open my GitHub one more time. Flight software. Yeah, so this is the readme that we want to take a look at. Never mind. So how to set up? Yeah, let's read the protocols. So for the hardware setup, that's mostly on the the design team. Let's look at the launch sequence. So we'll make sure that all the pyro channels are set to low, and the very first few lines of the code have a hard-coded function for checking if it's upright. So we have to write a function which uses accelerometer and check if the rocket is standing upright or not. Do you guys have any idea how we can write that? So the first step will be, let's write the header file for the accelerometer, and then the second step will be to write a method in the class which checks this. All right, let's begin. I'm gonna open this in my Visual Studio Code. Is my screen visible, by the way?
Yeah, I can see.
Okay. These are a couple of header files that I made. Yeah. So I did write something for the BMP. This is also something I wrote. This is not the code that you sent me. This is a different one. I'm not sure if they're similar or not. I can check real quick.
Oh, the other one was the one I wrote was just test, like, just to show it's working. That's all.
Let's see. So you're not using any tiny GPS library?
Yeah, I wasn't using, at least like from what I got, it wasn't. I didn't use any external libraries. I think it was everything's from. I need that library for it to work. Tiny
You
GPS
don't.
plus.
It's not a necessity. It's just some functionalities implemented in that library. But that's a good thing
Okay.
that you wrote without that library.
Oh yeah, because I think it can make the code run faster if we don't use too much
Definitely.
like bloated. Yeah, but I'll look into it. Do you still do you want me to make my own as well, or do you want to use the one like test out the one you already written?
I think we should be able to use the one already made, because this is like the functionalities this library have. Let me just show you.
Mm-hmm.
Like, it's a lot of functionalities.
Oh, dang.
Yeah, and not just that. So this uses another library. It's called Tiny GPS Plus. Um, limits library. Wait, where's Tiny GPS Plus? Oh, never mind. They've kind of. So what happened is, like, in the GPS community, people made a library called people made a library called GPS, then GPS Plus, which then got converted into GPS plus plus. But the thing was that those libraries were really heavy to run, um, which is kind of like strange. What could be there to run in a GPS, right? That's the thought that comes to the mind. But yeah, they were quite heavy, quite demanding on, like, small small embedded systems like ESPs and STMs. So there's another version of those library called Tiny GPS, which is like a tiny version of that. These are pretty lightweight libraries, and most of the functionalities are still in them, even though they are not as demanding. So yeah, so that's the kind of like the reason why I'm using that one. Then hardware serial library, that's just for serial communication between the GPS library, the GPS module and the ESP32, because they cannot communicate otherwise. If you remember, there was TX and RX pin, right?
Right.
On the GPS. So those pins are for basically. Um, okay, so our first goal, let me just define it in the chat. Um, we'll start from here. Protocol by protocol. So we have to write a library for the accelerometer. I'm gonna put it on the software. Let's do it for avionics actually. Okay, so we're gonna do accelerometer. Accelerometer library. Header file actually. Header file. And implement
It's 6 o'clock.
a function that can check if the rocket is vertical or not. As per the protocol. Okay, so do you have any idea in mind, by the way, Chisholm, that how can we implement something like that?
Making sure the rocket's upright.
Yeah. Using
Okay, so we're using the accelerometer, right? So what does the accelerometer measure the speed? Or sorry, I don't remember what it does again.
as the name suggests, it measures the acceleration, linear acceleration
Oh, okay.
in X, Y, and Z directions.
Mm. So to check if it's all upright. I don't know, because when I think of being upright, I think of a gyroscope. That's the first thing that comes to mind. But
Let me give you a
let me
hint.
think.
So like Earth basically pulls everything inwards, right, towards it.
Mhm.
That is called
Right.
like a force, and
Oh, gravity. So we
yeah,
can use like the physics of
right,
yeah. Okay, that makes sense actually.
right. So let's say our sensor, right? A sensor is kept on the ground, and the X and
Hmm.
Y directions are in the plane of the ground, and the Z direction is coming upwards. Let's just say.
Right.
So in the along the Z direction, the value of acceleration that we will be able to read from the sensor will be very different from the X and the Y values.
Right.
So the sensor will give us three
So
values.
so my thinking is we can calibrate it so we can get a constant x and y components. So it's not, it doesn't have to be zero, but I think ideally if it's upright it'll be zero, correct? Like the x and y components will be zero
They
because the only thing that's
they will hardly ever be zero. They will be like some random values.
but
Yeah,
what matters is that they're really small, correct?
right.
Okay,
Smaller than the
I
Z
see.
ones in the magnitude.
Mhm.
So the logic will be something like, um, so we would know, like, our team will know how we are placing the sensor on the avionics. Let's say
Right.
if the x-axis is along the vertical, like along the roll axis, then we will know,
Right.
hey, if x value in like the accelerometer value, like the x part of it, is more than the y
Mhm.
and z, so we can write a function like that. We know that the rocket
Right.
is vertical. All right, let's.
So the function is checking if the x value is greater than the y or z value.
Kind of like that, yeah. The
Oh,
greater
okay.
by
But don't we
ourselves
have
can be
to
1.
pre-calibrate it first, or is it? Sorry, I'm just trying to see like.
Yeah, so you're right about that. We will actually calibrate it. Let's say the value, like, let me just show you one node. Nope, 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 nope.
Those the Apollo computers.
Yeah, that's the finite state kind of diagram for Apollo 11 computer.
It's crazy.
Yeah. So I don't have my pen tab with me right now, so pardon me on the drawing.
Mhm.
So let's say that this is a rocket. And we will know how we are placing the avionics stack in here. Let's say this is our accelerometer, right? And let's say this is in the plane of the rocket, and so this is the roll axis. So this is the roll axis. Let me just write it. And on the accelerometer there will be like X, Y, and Z markings.
Mhm.
Just to show you here. Let's say this is X, this is Y, right? And then let's say Z is coming out, so the coming out is represented by like this. That's our Z, right? And because this reads mostly voltages, so we're gonna have some values, some 3 values from the sensor, like voltage along X, Y, and
Right.
Z. Out of these values we're gonna have to implement some logic, right? These values will be very random. Let's say in this situation, when this is on the ground, standing upright, the situation might be something like might look like 0.2345 or something, and then these might look like minus 0.134. Yeah, the values might look like this actually, or at max it could look like 0.6 actually. So this value is like pretty huge as compared to these two, right? And these
Right.
two values are kind of comparable,
Mhm.
kind of close to each other. Now we will say, let's calibrate these values. Let's convert these voltage readings into meters per second squared, right? That's
Okay, I
the
see.
acceleration. But that'll
Yo, yo.
Hey, what's
yo,
up?
VJ, how are you?
Hey, I'm good. Hold up, I gotta switch to my laptop.
Yeah, all right.
No,
Second.
it's good.
So the meeting is being recorded. I've decided to like upload it so that everyone can see how we are developing the software. So like I don't have to tackle all the questions, all the same questions again and again.
Okay.
Yeah. Do you have your laptop right now? Let's do this, right? I'm gonna write this one, and then the second task we'll do in the Chisholm's computer, and the third task we'll do in the VJ's computer,
I think that's a good idea.
right? Okay, let's go with that.
Yeah.
So here's the thing. VJ, I was telling him, hey, how can we do the first task, which is this one? Make sure you're listening. I cannot hear him.
Listen, I just had my mic muted.
Oh, okay, okay, cool. Yeah. So the first task is like we were going sequence by sequence as per launch protocols. The first task is have a hard-coded function for checking if the rocket is upright or not using the accelerometer data. Okay, so to read the accelerometer data, we need to write the header file for the accelerometer sensor, first thing. And the second thing to complete this task is to write this function which checks if the rocket is upright or not. So we have to think of a logic that can convert these readings from the accelerometer sensor, these three voltage readings that are coming from the accelerometer sensor, which represents the acceleration along x-axis, y-axis, and z-axis. They will not be in meters per second square. Why? Because they are voltage readings. We have to apply some formula to convert it, and that formula must be given by the guys, the folks who actually fabricated this sensor. So let me see which exact accelerometer I have here with me right now. It is GY61. So let's see the conversion formula.
The GI61.
GY.
Oh, okay.
Yeah. Conversion. Okay, so that's kind of like the formula here. They're saying whatever the value is, subtract 337.92 from it, divided. Wait, what the hell? Yeah, that's your numerator. Divided by 6.44, multiplied by 9.8. Well, let's just copy and paste it for now. But wait, he's saying I have a problem calibrating my GY61 accelerometer on an Arduino Uno to get the values in meter per second square. Oh, let's not trust this one because this is only a question.
Maybe you can look at the app. Maybe you can look at the answers.
There was no answer. That's what I look for.
Oh.
Yeah, I have a problem. Damn, it's the same guy.
Oh.
Okay, let's just look at the
You,
documentation. Wait, what did you say, VJ?
I was gonna say look at ChatGPT, but there should probably be some documentation.
Nah, you're right, bro. Let's just save our time.
Yeah.
GY61 voltage conversion to meters per
Wait,
second.
I have an idea. Maybe after you ask it for the prompt, maybe you can also like ask it where it gets its sources from.
Yeah,
So like we can use that as reference for other things in the future, maybe.
right. Yeah, so by the way, GY61 is the name of the module. This is the exact accelerometer that is uh, on that
Oh,
module.
that shit.
Yeah.
Oh, okay.
So that's the reading.
Hello.
Yeah, you're saying something?
Oh, wait, are you talking to me or the person who just joined? Oh, never mind.
He left.
Oh.
So yeah, they're saying basically whatever the upper voltage is subtracted by the 0G voltage. Let's say our here in this case, only the x-axis is facing the Earth's gravitational acceleration, the G, and y and z-axis are not facing anything, right? So whatever value is on the y and the z, just subtract it from the upper voltage and divide it by 0.3 volt 0.3 and multiply by 9.81, which is the value of Earth's gravitational constant.
Interesting.
Wow. So this is the sensitivity. I see. Let's do that. Let's just do it right now and run it and see the readings. Yeah, so this is the kind of like the code that I wrote for that sensor module. Basically, I've imported the hardware serial library. I have imported, yeah, just one library. This is the kind of like the class that was established in this library. I'm making an object of that class, and I'm picking two. I'm not sure what this represents exactly, but this might be the name of the sensor. Like for 2, it might be referring to the GY61 that we are using. For 3, it might be referring to GY521. And these are the pin numbers. Let me just verify the schematic real quick. I'll try if you guys can see it or not. I'll switch to my main camera. Okay. Let me just connect the schematic real quick. I was trying to test out the GPS code written by Chisholm, but it didn't work.
Ooh.
I don't know what to do now.
I mean, we'll just.
Make sure to include the what's the thing, that thing, the serial number in the like in the imports, right?
Yeah. Can you take a screenshot of this thing?
Oh, the number, please. It's a bit blurry. We'll wait until
There's got to be a better method.
Just write it down. Okay,
wait, it's.
let me call it out. Just write the pin numbers, like the pins down. VCC, X out, Y out, Z out,
Okay.
and GND.
Okay. Yeah, I gotcha.
Right, and then I'm gonna flip them. So from left to right will be for you from down to up. That makes sense.
Okay.
Yeah. So the first one was GND, right?
Oh, oops.
The first one you said, or like the first one?
Just flip it. Whatever I said, just flip it because I flipped my module.
Oh yeah, you're right. GND is the first one.
Yeah, let me hook that up real quick. GND to GND. Yeah, and then the second one.
Z out.
Okay, Z out. Let's choose the orange color for the Z one. And I'm gonna plug that into the G21 on the ESP. Can you write it down?
Wait, hold on. Yeah, I will.
Orange.
Yeah, orange for Z out, you said, right?
Yeah.
Mm-hmm.
Yeah, and I've connected that to G21 on the ESP. And then the second after that, what pin was it?
Y out.
Y out, yeah.
Okay, I've connected Y out using the blue wire onto. Wait, I cannot use this one. I cannot use this one either. On G19.
G19?
Yeah. And the only remaining one is the X one, right? X out.
Yeah.
Yeah.
I'm connecting that to G18.
What color you got?
Yellow.
Alright.
Yeah, and finally for VCC, I guess that's what's remaining, right?
Yeah.
Mm-hmm. Wait, do you have a color for ground?
Black.
Was ground red, right?
Ground is black.
Black. And is it a port number or is just connected to the ground on
It's
the?
just the ground. It says GND, so don't worry
Oh,
about that.
okay.
Yeah. Yeah, so I just connected this
Oh, okay.
module. This is the GY61.
Mm-hmm.
Kind of looks fancy when the lights blink, right?
All right.
Yeah. Yeah, let's
Like
just
VCC, what?
yeah, and I have kept it on the ground with Z axis, the vertical axis, and X and Y are horizontal, like they're along the ground. Can you also write this down?
Mm.
Say what again?
Z axis is the vertical axis, and X and Y are along the ground.
Let me get like a little picture for it.
Mm-hmm. Let's do a test real quick.
Hey, what's up?
Yo, what's up?
Yo, how you
Doing
doing?
good, doing good.
Cool. So what I missed? Are we all online, by the way?
Yeah.
Damn.
Yeah.
Um,
Yo,
So this meeting is being recorded right now. We just started just started implementing. Wait, where is it? This part. So we are going step by step in the sequence, and we are implementing everything. The first implementation is on my laptop. The second one we are gonna write in Chisholm's laptop. After that, VJ's laptop. Just so that like everyone is interacting. So the first one says have a hard-coded function for checking if the rocket is upright or not, using the accelerometer data. So this includes two steps. First, we have to get the data from the accelerometer, so we have to write the header file for that sensor module. Second step is writing a function which converts the voltage readings, which will be random. They will not be in meters per second square. They will be random voltage readings along x, y, and z axis. We have to convert these three values in either true or false, if the rocket is upright or not. We will abort the launch if the rocket is not upright. Yeah, so I'll show you
I
around.
love the free body diagram.
What'd you say?
I love the free body diagram.
Wait, I can hear you. Like your voice is muffled.
I think he said he loved the free body diagram.
Oh, okay. That was hand drawn, man. I don't have my pen tab here. Okay, so this is the header file that I wrote. Or it includes this library hardware serial so that my ESP can communicate to my the sensor. No, wait. It don't need to. Wait. The X, Y, and Z values are analog values. They don't require serial. I don't even know. Yeah, it's for so that my ESP can communicate to my laptop. Yeah, UART E22 module. I just created an object of this class for non-software people. Just bear with me for a second. You'll understand everything. And these are the pins. So yeah, let's define the pins now. I'm pretty sure you guys documented the connections, right?
yo,
Can you tell me real quick what is the wait we're gonna have to write another one because this is for MPU 6050 GY. I'm gonna name it real quick, GY61.h. Yeah, screw that. Let's just ask ChatGPT to write that for us. Okay, give me a C++ program to read data values from this sensor via ESP32. Can you tell me the connections real quick or paste in the chat?
I mean, ground is, Z out is connected to G21.
Oh, let me just copy and paste it, right?
Yeah.
Oh wait, it does not have the ESP pins, corresponding ESP pins. Oh, it does. G19. Okay, I'm just gonna paste this. I can remove VCC and GND from here because they're not transferring the data. X and Y are on the ground. Or I can also remove this. Yeah. We'll dissect this code real quick. So these are the pin values. 18 number is assigned to the 18 pin and so on the ESP. And for the GY sensor, they're defining the 0G voltage. If you remember, yeah, for those people who were not here just a moment ago, this is how you convert the voltage output from the sensor into the acceleration into meters per second square. You just subtract 0G value from this output voltage. Now the voltage that you have is proportional to however much acceleration the sensor is facing right now. You just basically shift it to 0 by doing this step, and then you divide it by the sensitivity. You can calibrate this number. Sensitivity is just a number. You can calibrate it on the fly. Let's say you put X and Y axis along the ground, so they should have 0 acceleration, but they will not have 0 voltage. You will subtract that non-zero voltage from the Z axis, which is perpendicular to the ground and which is facing 9.8 meters per second square, the gravitational acceleration due to Earth. And you will divide that thing by a number which makes this value 9.8. That's how you will find out the value of sensitivity. Let me demonstrate that real quick. If it confused you, it'll be clear. Okay, so as usual, we are not gonna include. We can. Okay, so Arduino.h will be included not just here, but also in the GPS. Like, also before I start writing this is the structure of our code base. There are 3 main folders. One folder, the first folder is library, which will have all the header files. Second folder is the source. This will have the main flight software using all these libraries. I have this all of this thing commented out. Why? Because right now I'm not writing the flight software. I'm testing the tests. So I'm doing the unit testing, unit by unit. The first unit is the accelerometer module here. I'm gonna include this file gy 61 that we just wrote over here. This is gonna give me an error though. Why? Because the test folder does not contain it. So I'm gonna have to go a folder back, and then in that folder there's a library folder where you can find the wait, why is this tripping? GY61. Yeah, there you go. Now there should be no error. That's how you include the header files .h. Okay, let's see. Yeah, these are the pin numbers that we have right now, but we don't want to write so this is not the structure that we are aiming for. our final structure should be similar to, where's the SD card one? Yeah, to this one, where we made a class and we defined a method on that class. So whenever we will use this SD card module, the header file, we will make an object of this class, and we will use this function, this method on that object to connect it to our ESP, which is the startup function, start the module. Yeah, and the rest of the functions I haven't written yet. One of the functions will be to write the values. It will go like this. Let me just show you. So the syntax in C++, if you don't remember, is you write the output data type, then you write the class name, then you do 2 semicolons, then you write the method in that class, and then you take the input parameters. The input parameters cannot be void this time. This time they will be something string. I think string is not a data type in C++, right?
I didn't know that.
It is not. You have to import some library for it, string.h.
Yeah.
And then it should be no problem. Let me just ask ChatGPT real quick. What?
If you want, you could do like a chart array. But I think it's doing a bit much.
What'd you say? My bad.
If you want, you could try to do like a chart array, like in C.
Oh, okay, the chart array.
But I'm not sure. I don't know if that'll be like. Yeah. Wait. Can you hear me now?
Yeah, I can definitely hear you. I got.
Oh, okay.
Yeah,
Okay.
you're right. Actually, let's just not even use strings. We can also take in numbers, right? An array of numbers.
I mean, sure. Yeah.
Yeah, we could try that. Yeah.
Yeah. So it's gonna be int. What should I call it? Damn.
Well, what is this supposed to represent?
Array. I'm just gonna keep it like that for now. Wait, why is this giving me an error? Because
Do you need like to dereference it or something? I'm not sure if it's different from.
oh, let me just try that then. Nah, it's still giving me an error.
Well, I mean, you have another function called startup, so it might be
you're right.
that.
You're right. Fuck, bro. Yeah, you're right. So I'm append. Let's call it append. It's still giving me an error though. Wait, why is it giving me that double thing in here?
You have to declare it at the top, maybe.
Oh yeah, we do. That's why. So in the class, I have to declare it. I cannot keep that function private, so I'm gonna keep it. No, wait. Let's just keep it private. Nope. Let's just keep both of them public. Let's keep this also public. Yeah. Hey, I have a quick question. You guys are CS, right? If let's say I have startup method here, and I include two versions. Let's say I include 2 libraries here, and both of them have this method, and both of them are public. Will that be a problem? No, right?
I mean, you might have to you might have to do like an additional identifier. You know, like like a not a self dot, but like whatever the library would be like from like a do a from import statement.
Mm-hmm.
Yeah, just to specify.
Oh, okay. So I got your point. Yeah. But also like at the same point, let's say I have made an object of this class, right? Saying something like SD card, then I'm passing in nothing because nothing is required really. Let's say I created object saying SD card, SD object. Let's say I did that, and then I'm using this, right? Oh, let me just real quick change its name. SD card module.h. Yeah, well, let's say I created this object right here, and then I'm calling this this function, startup function, SD object dot startup. Wait, why is it giving me an error? I don't need to do that, right? Wait, why, bro? Do you guys have anything to say here?
No, I mean ChatGPT might be a good help though.
Yeah. Okay,
Say
let's.
why the object has red underline.
Yeah. Well, actually, the future will never like.
No, actually, I know the reason. It should be two semicolons. No, it's two colons instead of a dot. Try two colons.
I don't think you need two semicolons while using the method. You only need that while declaring it, while defining it.
Oh,
Yeah.
I might have been right. My bad.
Or maybe that'll be dumb.
Wait, did you include the SD card object?
Yeah, I did.
Oh, I see.
I did here. Otherwise, the error would be here, not down here. You know.
Oh, I see.
Yeah. Yeah. Let me just copy the ChatGPT code in the GPS thing.
Are there any methods in there? Oh, it's void. Never mind. Sorry.
See if they are using. Yeah. So they like the syntax is correct. That's how you use it. That's kind of strange. Oh, maybe it's Oh, you're right. Oh my god. Okay, so the thing is, I have to put this in int main or not even that, in setup. Yeah, now there's no error. Wait. Really? Does it have to be capital? Yeah, there you go. Bro,
Nice.
we were so dumb. So like
Nice.
the methods have to be inside the setup, either the setup or the loop. Thank God I was able to do that without ChatGPT, because like it's live and like it's being recorded.
True.
Yeah.
Yeah. Okay, so we have the startup here, we have the append here. Let's call append in the loop. Append. So the logic might be something like you start it up. If that function returns, so it is gonna return you either true or false. If that returns true, if that thing equal true.
Well, you could just do an if. You wouldn't even have to. I mean, I don't know how you like need to declare it, but if you just do if SD object dot startup, I think
right.
that's like
You're right. If that thing exists, I mean, if for existing, it have to be either. It just have to be not zero. Yeah. And if it's not zero, it is true. And if it's true, then we can move on. Otherwise, just or the way to do this. Yeah, let's just keep it not. If this is not. Yeah, let me think.
that would be like a.
Yeah.
I guess like we don't do anything at this point.
No, you just return let's say an error code, you print serial printf that SD card fail, launch aborted, and we're gonna return, let's say 3 or some number because we have int. Yeah, and if that does not happen, then we can move ahead, no problem. Then I'm gonna print SD card successful, and that's pretty much it. Yeah, so we got an idea how C++ works and what kind of software structure we are following here, right? That was the purpose of this small demonstration. Let's move back to the ChatGPT code and just copy that and write down the header file for this gyroscope. Sorry, this accelerometer. I'm gonna close it here. I'm gonna remove this file from here. We only need this one right now. Let's restructure this into classes and functions. Okay, so this one I'm gonna do it. The next Chisholm, then VJ. Yeah, let's go class GY61. Here it's gonna be public and private. Public, private. In public, let's not wait, private goes up. Let's keep everything in public for now. We'll see if we want to push anything in private later. Here it's gonna be these 3. And why is this an error? It's not. Okay, cool. Then these, and then functions to read analog voltage from a pin. Okay, let's put this function as a class function for which we need GY61, 2 semicolons here. Also, there's like a strange thing I just remember. You have to put a semicolon here for this to not give you an error. Like for this to be complete, you have to just put a semicolon here. Also, let me put this comment up there. Yeah, you see how that error went away. Yeah, read voltage. We have to declare this function up there in the private. Sorry, in the public. I'm gonna call it function declaration, methods declaration. Here it should not give me an error no more. Yeah, there you go, the error went away when I put that semicolon here. Okay, so we are taking input as a pin, which could be any of these 3 pins, and then we're gonna read the values. Let's actually do this. Read voltages. I'm gonna rename to read voltages instead of that. Before that, I'm gonna print this. Copy. Read voltages. I'm gonna use read voltage function. So if you are not able to follow up, so what I did here is I copied and pasted this function 2 times, and I changed the name of one of them to read voltages. And let me also put that up there. Here, read voltages. Or I don't think I need, yeah, let's just use that. Okay, so read voltage function takes in a pin input and then outputs you a value, which is your acceleration value, which converts your voltage into acceleration. And I'm gonna use this function in here, and I'm gonna rather return a list. We'll return list of x acceleration along x. Yeah, that's what I want to return instead of a float. And I don't even want to take in the pin. I don't want to take anything from here. Okay, so I also have to update this voltages declaration here. Yeah, and the return type should be the list of floats. So how do we do that? I guess like that.
See. Give me a second.
How do you return?
Wait, the function itself is supposed to return a list of floats.
Yeah.
It should be like in an array, or just.
If you do float star,
Yeah.
that'll.
Float star. Oh, you're right. That worked. Okay, that means the list of floats. Wait, how does that work though? Like, star is a dereference operator, right? Oh, I think it's some pointer to float rather than just a pointer. I mean, rather than just a float, maybe.
Yeah, I mean, that would make sense
Yeah,
because you can only have one like endpoint pretty much.
right. Because in C language, so like let's say a variable name, right? Variable one. This means just a variable. It could be int, it could be float. But if you want to make, let's say, this variable represent a list, then you have to use this kind of syntax. Star really does not remain, like it doesn't stick to int, which is also correct, but it's just the weird way of writing syntax. They just do it that way. This is also fine. Here, this is no longer int. This is a pointer because they have a star at the end, which points to a list of integers. And here it makes sense because now this, which we can also write like that, is representing a list of floats now, right? Okay, so I'm gonna return 3 things in here. Wait, I have to also make a list. So I'm gonna make a list. Accelerations. Wait, why is it an error? Okay, yeah, my bad. Yeah, list of accelerations. Wait, what's up with that?
I think you need to put the brackets in front of the float.
Really?
Yeah, I think.
No.
Yeah, I think so.
It is giving me an error.
Hold on.
No, I think this is how you do it. You don't put anything in here.
Yeah.
Yeah, but how? But the issue is that like it's just dereferencing a variable. How can we tell if it's like a list or not? That's the issue I'm having.
It is a
Well, my interpretation is that just it can access any memory position within the range of the length that we declare the list to be.
that kind of works. Why is this tripping?
Okay, I'll just look up how to do a list of do a list of
How to initialize a float list?
yeah, in CPP.
Initialize a float list in C++. Okay, well, let's see. That's so freaking strange.
we have to use a separate library?
Without. Yeah.
I've seen you. Okay, maybe just try like float name and then bracket in the declaration on the left hand side with
Okay.
the size.
Wait, let's go
And then
step by step. You said let's try.
yeah, just float and then I guess acceleration bracket and then just equal the variable. So no star.
You said equal to the variable itself.
No. Sorry, the values.
Okay, like that.
It's not working.
Yeah, it's not working. It's the same error. Okay, let's see what ChatGPT have to say here. So it is giving me a couple of choices to do that. Previously it gave me the vector thing, the vector library, and you just call std vector flow list. Okay, this is how you do it. You have to put curly braces. I guess that's about it.
Oh yeah.
Oh my god, yes. How can I forget that shit, dude? Lists are.
Wait, isn't that like a Java thing? That's oh never mind. That is C. Completely forgot about that.
Yeah, man. Oh my god. Okay, it was a
Yeah.
piece of cake. Yeah. So instead of
Yeah.
1, 2, and 3, what we're gonna do here, we'll call this function here read voltage, and in here I'm gonna put in the X pin, which is literally called X pin, and here I'm gonna put in Y pin, here I'm gonna put in the Z pin. Right now I'm basically I'm just using this one function and I'm getting the entire list of accelerations, and I'm gonna return it. Alright, and let's go. So the first step in this task is done. Congratulations. So this part is done, getting the accelerations. And the second part is writing down a
Nice.
function which basically checks if it is upright or not. I'm gonna wait, it says voltage to acceleration. Oh, my bad. We also have to call this function on top of the value of this, because this is only convert to voltage. This is the voltage itself. Yeah. So let's do that.
So just wrap that inside of voltage acceleration.
Is there any way we can do accelerations? I just update this list and say acceleration
Like an acceleration for each of the components.
voltage to accelerate. Is this? Yeah, it's just the Python thing, I guess.
Oh, okay.
Yeah, like you can do this in Python. You can call a function on the entire list and
So
update.
do we just have to do it to the individual values then?
Yeah, here we have to. Let's just do that. Okay, it's not that bad. Oh, we can also copy this thing here. We could have copied this entire thing the whole time, dude.
Oh yeah.
Yeah. Yeah, let's just copy this entire thing. Or let's just fucking rename this as read accelerations. Wait, hold on a second. Yeah. Void. I'm gonna change it from void to int. Why? Because in our main function, it will always return int. and even in a loop function it will always return int, right? So we're gonna have to return an int in the loop function also. It's kind of confusing, just give me a second to think. Yeah, gy61, I'm gonna rename this entire thing. So what is this doing? This is reading the voltages, converting those into acceleration values, and also printing them. But what we can do is we can return a list of these. So I'm just gonna copy this syntax here. I'm just gonna paste it here, all these three accelerations: x acceleration, y acceleration, and z acceleration. Yeah, this is what we are gonna return accelerations. But then this violates the int thing here. I'm gonna change it to float. And the read voltage function is kind of tripping over here. Read accelerations is gonna take in nothing. No, it's gonna take in nothing, void. And I can remove this from here. We don't need the setup thing anymore. Why? Because setup and loop should only be in the main file, in the CPP file, not the header file. Header file is .h. This is just the library that we are gonna use in the future. Yeah, voltage to acceleration is kind of tripping. I think why did that happen? Does anybody have
I mean, it might be. Do you have it declared at the top?
they are declared here.
Read accelerations.
These constants, 0g voltage.
I mean, I was talking about the function.
The functions are still here. This function.
Wait,
But you
are
have
the,
to- you have to
are the
declare-
constants? The constants should be out of scope, right? Should be in scope, right? Because
You have
it's
to
seeing them
declare-
like
Oh,
yeah, they should be outside the function
I got you.
because they're in the scope of that.
Yeah, I got your
Yeah,
point.
they can't have access to it. They're out of scope.
Yeah, so if you declare the read accelerations at the top, that'll give it access to those.
Right. You're smart.
Oh, let's talk about the No, I'll talk about the constants because the constants have to be declared outside of that constructor because they have to be accessible for all functions.
But to fix
So they have to be.
But to fix that, I have one more way. I can also say, let's make this
Yeah,
method.
that's right.
Yeah, let's make this method of this class. And
Oh yeah, you're right about that.
and declare this on top. Yeah, look at that, beautiful.
Oh, yeah.
Guys.
I think that's better as well because it's like because at least they're not like global, you know. So
Yeah.
Right. Okay, so I think we're pretty much. No, wait, there's some error here. Okay, we cannot be returning a list when that is float, so we could just gonna do that, and it went away. Cool. And we also have to update this thing now. Float star. Wait, why are you tripping now, my boy? Yeah, that's what I thought. Okay. Let's put that thing. Let's call that thing in here. I don't want SD card anymore. Remove that. Okay, so this file, let me just comment it out. This file is supposed to be a test file for GY61 module. It is a part of unit testing that we do here at RocketTech. Okay, so what are the variables that I have to define in here? Okay, so these are by default defined unless I want to change their values. So the first step will be to create the object, right? Initialize the gy61 object. For that, I'm just gonna use this as my data type, and I can assign it a variable name. Let's call it accelerometer. Okay. Also I want to include, okay, so I already have arduino.h. Why? Because this library that we just included already have it. So I can directly do the serial.begin. This step is required in the setup thing. Why? Because otherwise your ESP and your laptop will not be communicating. And you have to define a baud rate in here. If you go down here and you have the thing platform IO thing set up rightly, then you should be able to see this something called a serial monitor. And wait, serial monitor over here. Yeah, you can start monitoring, but nothing,
It's 7 o'clock.
but nothing is coming from the ESP as of now. So let's try to get the values from that thing. Also, the output that will come from your ESP will be shown here only if your laptop and ESP are communicating. So we have to match the baud rate in here, 115200. See, now there's no error. So this is, you can think of this number as the bit rate. These are the number of bits that are being going back and forth between your laptop and the ESP. Let's go ahead and use this accelerometer thing. Okay, one more thing. I have, like, this is not a good header library. Why? Because the header library should have a startup function. What if your accelerometer is not even working on the flight day? And what if the flight is like too costly, like the logistics are too costly, you cannot reschedule your flight and you still have to flight, you still have to like launch even with the faulty even with the faulty accelerometer that day. So the protocol should have something like override. We want to check if that thing is working or not, for which we need a startup function. Let's do that. The logic that is coming to my mind right now to check if that is working or not is this. Where should I put it though? Let's put it all the way down here. Gy, wait, we're gonna return bool. Why? Because there can only be two cases if that thing is working or not. gy_61, and I'm gonna call it startup. It's gonna take in what value? Nothing, actually, void, and it's gonna return true. But there's some other code which first have to run successfully, and then this function will be returned. The true value will be returned. What is that code now? That will be let's try to read the acceleration, and if we can read it, try to read voltage values actually. If we can read it, then gy61 is working. Then we're gonna return true, right? Yeah, otherwise we'll return false. Okay, let's put this in an if condition. If whatever that condition is working, then we're gonna return true. Else false. Return false. Okay, what that condition will be? That condition could be. Wait, let me see. We have defined a couple of variables x, y, z, but we haven't defined the value, like the voltage value of at x. So that variable will never be created in the first place if analog read pin is not working. But wait, holy crap, this is like a rabbit hole, but we have to do it.
True.
So the thing is, this analog read function reads the pin voltage on the ESP. It don't even care about if it is connected to your accelerometer or not. It will give you the value of voltage on that pin. And so what that means is this will always return some value no matter what, even if you don't have anything connected in the first place. So we cannot just check it that, hey, if read voltage that thing exists. What was the function name again? Read voltage. If read voltage exists, let's say x pin, then we can return true. So this logic is not going to work. So we have to think of another logic. Do you guys have any idea?
So like we're trying to find like what to return if
No, we're trying
just
to find a condition which can tell you if your accelerometer is even connected rightly to your ESP32 or not. Why? Because this can give you any voltage, literally, like it can gaslight you into giving like a noisy reading, even when there is nothing connected to your ESP on these pins.
Oh, I see.
Yeah. Because analog read does not care about what's connected there. It only cares about the voltage of that pin.
So just trying to check if it works. That's all startup does.
Yeah. And
I mean, you'd have to have like a correct. Are you talking about like a correct value calculation?
Yeah, some logic that can tell us if they're like some random ass values or are they some sensible values, or you know what I'm trying to say, because like there will be random
Yeah,
values
real values.
if there is nothing connected, but there will be something sensible in the value if there is something connected.
What if is it possible we can try to do something like that without calibrating it first?
Yeah,
On startup it should be operate, right?
Yeah. Okay, so wait, correct me if I'm wrong, you're saying just forget about it right now and let's just try it.
I feel like it. I mean, there might be another way, but I can't think of a way without calibrating it first.
Yeah. There's one way in my mind though, like let me just share it that we are on this. So you know how vector sum works? X squared plus sum of vector, like a magnitude. You know this formula, if you have a bunch of
Oh yeah, for yeah, that's the dot product thing, right?
Yeah.
Is it?
Yeah.
Okay.
And for x, y, and z axis, we have, imagine, right? We have three vectors, one along x, one along z, and one along y. The sum
Right.
of those all should be very close to the value of Earth's gravitation.
Oh, okay.
You know why?
So the sun should. Oh, why?
Because this thing is on Earth.
Oh, so at least like so we're trying to get into like a real world like a value so we could check if it's like
Right.
we could use like these calculations already so we don't have to like calibrate or anything. We could just use these values to prove that we're on Earth basically. So it's actually connected the way it's supposed to.
Right. So if there are three vectors along x, y, and z, their magnitude, their resultant magnitude will be this. And
Right.
if we check, hey, if the resultant magnitude, okay, so how will we do that? Let's say we have a variable here, int, or not int, my bad, float, resultant,
Right.
or vector sum, and if that vector sum value will be, let's say, within a range smaller than or equal to 12, let's say, and greater than or equal to 18,
Right.
right? So if this condition is true, then I can like get, wait, my bad, 10. Then I can get, not even 10, let's put it 8. Then I can guarantee you that this is connected. Like the noisy signals, if you square them and add them and root them, they can never be close to the Earth's gravitation. That'll only be the
Right.
case if your thing is connected to an actual gyroscope. Right? Now let's declare this function up top. Yeah. But we have to define vector sum though. So what I'm gonna do right
Right.
now is I'm just gonna return true. We'll figure out, like we'll worry about this a little bit later. Return true. Yeah. So here's how the test will work. If gy, whatever this object is, accelerometer dot startup. So if this thing is not there, which is not this thing, then we're gonna return false, or my bad, or 0. Just to be sure, we will return 0 for success, or for failure, 1 for success. Why? Because this setup function is have to return int, right? So we have to choose. Yeah. Otherwise, just move on, and let's just print that thing out. Serial dot print. What value do we have to print? Wait, printf. Let's print out the accelerations. Okay. We have to declare a list, by the way. Accelerations. Float. Accelerations. Hey, why is this stripping? Yeah, it's not. Yeah, so we're gonna have to run a loop 3 times for printing that thing out, or we can do it manually as well. Let's just go manually right now. That'll be quick. Yeah, so in this list I want to store the values that comes from read accelerations function, this one. Okay, I'm gonna write this accelerations equal this function read accelerations, but this is a method of this object accelerometer. So that's what we have to write, and we also have to do this. Cool. So now this list have all of our values. Okay. And the way we're gonna print this thing out is you guys remember this method %d or %f for floats is called typecasting.
Yeah.
I guess. Is it called typecasting? if I'm wrong.
I'm not sure. I think it's specific to C and C++. Typecasting is where you're trying to convert like a type into like another one, like a float into an integer.
Oh, I see.
Yeah, but I know what you mean. I know what it does. Yeah.
Yeah. So we're trying to print out the acceleration along x. So I'm gonna write acceleration along x is this. Then I'm gonna have some space. Along y is this. And along z is this. Okay. Damn. So we are done. That was it. Let's try to run this. Oh,
Hopefully, does it crash?
also we need to delay it a little bit. Why? Because the frequency that this thing runs is in gigahertz, which is like 10 to the power 9, and but the sensor cannot output values that fast. So we're gonna have to put in a little bit delay. Let's say 100 milliseconds or 150 milliseconds for giving sensor a little bit time to like output a new value. You know what I'm saying? Otherwise this loop thing will run like crazy fast. Okay, let's do it. I'm gonna build this thing. We're gonna have some errors. We're gonna have to do some debugging and all that shit. So the error is in BMP. Let me just comment everything else out so that there is no error. Oh wait, what did I do? Yeah, GY, that we need. We're not gonna comment that out, of course. Kalman filter, there is nothing in here. MPU6050, let me comment this thing out. Also this thing, cool. Main GPS, yeah. Let me try to rebuild this. Cool. Wait, no way. Why is this giving me error now? It says we're not using this, right? Why is this thing giving me an error now? Okay, my
Sorry, are we still having issues?
yeah, there's some build errors, which means like libraries are not addressed properly or something. Some weird ass error, not in our code though. It says out of root I2C device.h error. Hey, my laptop is about to die. It's at 4%. I think we might gonna have to call this a session. Wait, let me try. No way. Bro, BMP is all commented out. I'm not even using this. Why are you giving me an error over there? Let me just restart my Visual Studio Code because like this trips sometimes. I'm pretty sure you've had this kind of moment. Oh, it didn't even ask me to save the project status, which is kind of strange. Okay, so
Yeah.